Hello and welcome to lecture number 44 of our course on blockchain and its applications, and we will continue our discussion on identity management. So, this is the second lecture on the particular topic of identity management. So, today we are going to cover these important concepts. If you remember, in our last lecture we motivated about why it is required that one should go for decentralized management of digital identities, and we had introduced the basic concepts of identity management. So, today we will go into the details of how this concept of DID works, and once again remember that we mentioned about this W3C recommendation. So, it is highly encouraged that you go through the W3C recommendation site as was mentioned in our last lecture, so that you will get more details of it, thorough understanding of how DID indeed works. And there are other web resources also that you can make use of. So, today we will see what is the overall workflow of DID, and then how indeed blockchains can be possibly used for implementing decentralized DID registry, and then we will introduce the concept of what are called verifiable credentials. So, the keywords for today's lecture are DID, of course, DID registry. We will talk about a particular type of blockchain called Hyperledger Indy, and then of course, about verifiable credentials or VCs. If you remember, in the last lecture we mentioned that this DID, and it has got this kind of structure. A DID resolves to a DID document, and this DID document resides in a verifiable data registry, and these DIDs are for some subjects, and these DIDs are created by controllers who can also update it if required. And as we mentioned that the subject itself could be also the controller. So, if the subject is itself certifying certain attributes, then it might be possible that it is the subject is enough to certify attributes. So, these are not really very critical attributes. So, it could be that the hobbies of the subject, or it could be the address and so on. So, which could be certified by the subject itself, but if it is an important attribute like say a degree certificate, where say the university is the controller which is certifying that this particular student with this roll number had completed this particular degree in this year, getting so much percentage of marks, or passing in this particular first class or whatever. So, these are not something of course the subject itself can do. So, it will be done by the controllers, but important point to remember is that in the architecture of DID there is this logically an entity called controller, and logically another entity which is the subject, and then physically it might be of course the same. But now coming back to this exactly what this DID is all about. So, DID is a unique address, so that universal resource identifier URI, that points to a location of that document, and then it has got these different components as is mentioned here. One is the scheme. So, scheme is always DID. So, when we are talking about scheme, so it is the DID, and then the DID method is the second one, which here we have named it as example. Now, if it is used for example on Ethereum, so the DID method could be Ethereum, which is a blockchain that we know about, and then for the remaining part we have a DID method specific identifier. Okay. So, that means that with respect to DID, this particular DID method example, this is a unique identifier. Now, in another DID method also the same identifier might be there, and hence the DID method along with the DID method specific identifier, these two together they would form a universally unique identifier. So, as is mentioned here that this DID method is a system that supports the DID scheme, okay, that how the DID would be resolved in this particular example. We have named it itself as quote unquote example. Now, very important that you go through once again these websites. So, one of that we had already mentioned in our last lecture, and that is this W3C recommendation. So, I am once again showing it to you for your benefit, is that you can take a look at this particular site, and along with that what is important is that whatever is mentioned here as that what is the part of this entire DID, this URI. So, you will get exactly those details here about what they represent, some more examples of it, and this is a fairly detailed document. So, it is important that you please go through this document and see what are the details of each of these individual components of DID, and also for this URI. So, you might be wondering what is URI and so on. So, you can go through this particular website also. So, this URI, this is an RFC. So, you can take a look at this RFC, where you will get more details about what is meant by URIs and so on. So, you can see this is RFC 2396, and it has got all the syntax and it has got all the details about different versions. So, it is once again strongly recommended that you can go through this site and get details of what are the various components of URIs. You can also see how URI and URL are related and so on. So, these are some of the important concepts that we will get from this document. As you can see that all these terms URI, URL, URN etc., are nicely defined here. So, that will enrich your understanding of what we are talking about. So, overall we see that this is how a DID would look like. So, that is the very first point that we need to understand, and also DID is simply a unique address, it is a URI that will resolve to a DID document as mentioned in our last lecture. Now, this DID document, so that is what will be stored, if you remember, in the data registry, the DID registry. Now, what is a DID document? So, it is a set of data that describe the DID subject. Of course, that is the purpose of these identifiers, the different attributes that compose the identity of an individual, and also it includes mechanisms such as cryptographic public keys that the DID subject or a DID delegate can use to authenticate itself and prove its association with the DID. Now, if you remember, we said that there could be some attacks if the identities are stored in centralized locations, and we said that the difficulties that were associated with were, one of that was how to verify the issuer of that particular identity, and also how one can verify the holder of that identity. And as you know by this time that we can always think of addressing these issues in the digital domain by using the concept of digital signatures. So, that means that if this identity that is being provided by a controller, it is signed by that controller, that means it can be encrypted, or some data associated with can be encrypted by the private key of the controller, then any verifier, if the can decrypt it with the public key of the verifier, then it is proved that indeed that particular identity was issued by the that particular controller. Similarly, if now some subject is presenting an identity, and also there if it can encrypt some data with his own private key. So, that is the private key of the subject to whom this particular DID refers to, then any verifier can decrypt that with the public key of the subject, and then it would be proved that indeed that particular DID or that identity was actually issued to that particular subject. But then it is also important that somewhere it is mentioned which are the public keys of the controller and the public key of the subject. Indeed, this DID document is going to have those public keys mentioned. So, that is what this DID document looks like. So, this particular figure again you will be able to get from this our previous website that we referred to here, the W3C recommendation. So, you will get all these details in this particular document. So, whatever we are referring to in this topic, so these are all from this particular website. Now, this deed document that has got two major parts, one is the properties and the representation specific entries. So, the properties are shown here and some of the core properties would be there like the ID. So, of course, who is what is the ID of this particular deed document that the subject that this deed document refers to, and there are aliases like also known as, then who is the controller, what is the authentication and the verification methods, the service and service endpoints means that if this is presented and if it is verified, from where can the verifier now contact this particular deed subject in order to get to the next level of the service. And then there could be certain property extensions like Ethereum address. So, as we said that this deed could be implemented in Ethereum. So, that can contain this additional information like Ethereum address. And now, if we look at the representation specific entries, so it tells us that what are the core representation specific entries like whether it is written in represented using JSON or using anything else like it is done using XML and so on. So, this information has to be maintained somewhere, because if the data is written in JSON, so one should be able to read that from the JSON format, right, and not try to read it as an XML document, and of course, the other way around also. So, these are all maintained. So, why are these done is that these are made very flexible. So, it is not tied to one particular type of representation. So, it has many different types of representations, and there could be some representation specific entry extensions also if required, and if these are not some of the standard extensions, there could be some unregistered extensions and so on. So, all these types of information can actually be maintained in this particular deed document. Again, remember that this is one deed document which corresponds to one deed URI and it refers to one particular subject. And we have deliberately shown it here that all these different concepts like deed subject, what it is, what is a deed delegate and so on, these again you can go through this website and get more details of it. So, this in overall is how a deed document looks like. So, we will take a look at one particular such example, because this is more like a generic representation, and now what we will do is that we will see one particular example. So, this is again in JSON. So, if it is in some other format, so that has to be mentioned here as in the core representation specific entries. Now, here we have one example of a deed document which is in JSON format. So, what we see here is that this is important to understand that we have the ID here. So, this is the first thing, okay, the ID, as we said that this is for a particular deed subject, and then we have the authentication. So, which talks about how this verification would be done, how this deed subject can authenticate itself. So, it is mentioned that it would be done using this public key multi-base, and it is written in this format. And then what is important is that it says that this ED 25519 verification key. So, all these are telling us that what is the mode of encryption that it is going to be used. Remember, we said that there is this public key cryptography which could be of different types like RSA and others, and it is not that everybody will be using RSA. So, there are different such possible ways of doing this public key based cryptography. So, it has to be mentioned that which one of those techniques are being used or being used here in this particular deed document. So, unless that is done, one will not know how to do the decryption. So, depending on what is the type of public key, accordingly the decryption method has to be chosen. And for that we also have this public key as is mentioned, and then if you look at this particular example, we have this ID which is the ID of the subject and the controller. So, we see that we have the same value for the ID for the subject and ID for the controller, means that this is an example where the controller itself or the subject itself is the controller. So, physically the controller and the subject are the same, though logically these are two different entities as we had discussed before. And here we have the service part of it written here, the details of it, where if you remember we said about the service endpoint. So, that is after the authentication can be done, then the verifier will go and get to this particular site which is called the service endpoint, that is this say some bar.example.com, where one can go and get the actual service. So, it denotes the ways of communicating with the did subject. So, this is important. So, it tells how to reach the subject, otherwise there is no meaningful use of authentication, because authentication would be done and then there would be something that this particular subject will be doing. So, that is where this notion of service endpoint comes into play, and this is specified here in the did document itself. And of course, as we had shown in our last slide, that we could have multiple such other types of information that are presented. We showed the more important ones, but you can have more such types of information maintained which can be used for multiple purposes. So, this indeed is a very flexible specification for did, and it can be implemented nicely using blockchain, as we have mentioned before and as we will also discuss later. But before that, let us just see what is the relationship between different components of did. So, if you see here that pictorially we have a did document and we have the did controller who controls the did document, can update the did document, and then this did document actually identifies a did subject. So, there is this did subject as we mentioned, and this did identifier. So, this did itself resolves to the did document, which in turn is describing a did subject. So, a did is an identifier which is assigned by a did controller to refer to a did subject, and it resolves to a did document that describes the did subject. That is a very precise definition of what is a did. And the did document is indeed an artifact of did resolution. So, did will resolve to a did document, and it is not a separate resource. And finally, that did documents reside inside verifiable data registry, as we have mentioned in the architectural diagram that we had shown. And of course, we said that the did controller also could be same as did subject. So, that is another example when the did subject and the controller are the same identity. So, we show that this did controller is equivalent to the did subject. So, that is fairly straightforward for us to understand how it can be done, and we have seen that example of a did document where it was similar to this, that the did controller itself was the did subject, or you can put it the other way, the did subject itself is the did controller. That means, that subject can self certify different attributes. Mind it, it does not mean, or you should not think that, oh, I can certify anything and people will be then using it. So, it is not like that. The verifier of course, will have to trust that if it was issued by a controller who is an authority like say a university or a board. So, then the verifier might be willing to use those particular attributes of the subject for certain types of applications which are critical. But if it is not a critical application and you do not need some such say authenticated body to certify, then the self certification of the different subjects can also be used. So, one could actually in this manner could do or process the notion of single sign on we talked about previously. It is possible that I could maintain my did somewhere, and wherever I want to log in I would simply present the did, and it is all about using my this public key and the digital signature that is there in the did document. So, if we see the did flow, first of all the did registration, we have this first step of creating the did document, and before that in step 0 the keys are generated, a public key and a secret key, and then this say the ID is did.registry1.alice, and the authentication method is using public key, and the controller also is did.registry1.alice, means that the controller is the same as the subject for this particular did. And then the step 2 is the registering of the did, and then this did document which is signed by the secret key of the controller. So, that is now stored in the verifiable data registry, and then one can authenticate the did controller by means of the public key using the digital signature. In this example is based on the signature. One can think of other options, and this specification indeed supports multiple such options. It is not that everything has to be done using the similar type of technique that we have mentioned so far in this particular lecture, but it has got a lot of flexibility in which you can actually carry out this process of authentication, and all these of course will be maintained in these documents as written here in this example DID document, and also as mentioned here that there are many such possible extensions and unregistered property extensions. So, one can add to the type of method that can be used for authenticating the controller and also for the subject, and the DID document gets updated. So, this is the DID registration, and then when say Bob wants to authenticate the subject, which is did.registry1.alice as is shown here in this diagram. So, after the registration has been done, now at a point in future, this is what Bob is going to do. Bob is trying to authenticate. So, what Bob would do is that Bob would fetch the DID document corresponding to did.registry1.alice. So, Alice will tell that, see, if you want to authenticate me, you go and fetch did.registry1 did:registry1:alice, and then Bob would go and fetch it from the verifiable data registry. Now, once Bob has done, Bob will have to first figure out that indeed it was signed by the controller. So, it will use the public key of the controller to see that this is a correct signed, digitally signed document, and also indeed it is for Alice, because Alice might say, oh, go and fetch this URI, that is mine. So, how does it know? Because the Alice's public key can be used now to decrypt that and see and verify the digital signature of Alice. So, once that is done, then this Bob can authenticate Alice based on the authentication method, which in this case could be public key cryptography using the public key PK that was generated in the step number 0, which was generation of the keys. So, the DID method security. So, DID registry ideally should enforce DID method protocol. So, that is very important. Now, as you can understand that centralized DID registry brings in risk. So, we have so far motivated ourselves to have everything decentralized. So, if this DID registry itself is centralized, we have the problems, and then one can manipulate the DID documents, change the authentication methods, and it might lead to denial of service, because if somebody can change things there, then the digital signature will not match, and it is also possible some censorship would be done, that the data registry can in some cases actually do its duty of verifying the identity, and some other cases say that no, I am not going to do it, and there will be this refusal to resolve certain DID documents at the discretion of this centralized data registry. So, that is not a good idea, and of course, there will be lack of transparency, that what is going on nobody knows. So, that is why it is important that we have this decentralized DID registry, that is the first one, and that is where blockchains come into picture, that blockchain can be used for implementation of verifiable data registry. As we can understand that whatever will be there in that verifiable data registry, that one should be able to verify, and that is what we talk here about transparency. So, if it is there in the blockchain, it is out there for everybody to see and verify. So, any node can join that blockchain network and verify that data registry if it is correct or not. If something has been changed, tampered with, so all this tamper evident property would be satisfied by the blockchain, and these are actually the methods that we talked about. These are implemented as smart contracts, as we have talked about before. That DID methods, of course, these are not simply lying there and somebody will verify. So, these are to be done in a systematic manner, which can be done by smart contracts, which we have studied already in our other lectures and in the tutorials. So, they would enforce how authorization is performed to execute all the operations, including any necessary cryptographic processes like verification of digital signatures and so on. And it is a transparent immutable ledger that would allow the verifiability of the documents. Any party can validate if a DID documents creation or updating of these transactions were authenticated or not. Indeed, it was carried out by the proper controller, and it was properly signed digitally by this particular controller. So, this verifiable data registry, as is shown here, that can be indeed implemented by making use of blockchain. So, that is the most important concept, and without the blockchains implementing such decentralized verifiable data registry indeed is not going to be very easy, and this entire blockchain network, this infrastructure which is available, that can be made use of for implementing such types of decentralized and verifiable data registry. Now, which of these blockchains? So, we have this side tree which is a protocol for creating scalable deed networks, and it can run on top of any existing permissionless blockchains like Bitcoin, Ethereum, etc. So, you can take a look at their details from this website as is mentioned here. And for a public permission ledger based registry, this can be done using Hyperledger Indy. So, if you see that Hyperledger has got multiple projects like Hyperledger Fabric, and then another important one is this Hyperledger Indy. So, here it is important to understand these concepts. So, we have said public, but permission. So, that means that it is public in the sense that any party can read the ledger and can verify it. So, it can be done by any party, but only some selected registered parties can write to the ledger. So, it means it is simple implementation in the sense that it is permissioned. So, to some extent there is a control on who can write to it, but it is public means that anybody can read and verify it. So, you see that it could be possible that the controllers are allowed to write to it for adding to the verifiable data registry, the addition and updating of the deed documents. But then once it is done, anyone, any verifier could always use it, or the user could, the subject could present it to any verifier as and when required. So, that means that it is in that sense public. So, if you look at this Hyperledger Indy this site, so again it is as you know, this is open source initiative where we can go through the details. So, these details you can see here. So, you see that it talks in the very first page, in the first set of key characteristics, that it is distributed ledger on for decentralized identity. So, that is the purpose of it, and you can actually have small projects you can actually execute on this Hyperledger Indy. So, that will give you a lot of insight in how to actually make use of Hyperledger Indy, and it is important for us to understand this implementation of decentralized these deed registries using Hyperledger Indy. And now finally, what is important is that we have so far talked about again decentralized identifier, but these are again digital identities. But if you remember in our earlier lecture, we said that other than this digital identity, one may need to bind it to some physical identity through the KYC process. So, there is this need for binding the digital identifiers, in this case decentralized identifiers or the deeds, to the physical identity of these subjects. So, deeds only allow a deed controller to prove its control over its deed document. So, this is useful to authenticate an entity with respect to its deed. Now, of course, that we have talked about all this use of say private key and the public key, or this public key and the secret key, as we have mentioned here instead of the private key. So, this PK and SK. So, this authentication based on PK, this can easily be done by fetching the deed document from the data registry, but then it does not reveal any physical detail. So, if some physical detail is presented, then that is only self attested by the deed controller, not any verified information. So, the deed controller can say something about this particular subject, but this is not verified against a physical identity. So, that is also something that would be important if this identity is being used for some critical purposes, including financial transactions or say for voting and so on. So, what is that we need to now do is that we need to see how we can bind these physical identities with the these DIDs. So, that is what it takes us to this concept of what are called verifiable credentials or VCs. So, we had the deeds and now we are talking about the verifiable credentials. So, the verifiable credentials data model, this is once again a W3C recommendation, and you can go through this website as well, which is now a different website, which is about the details for the verifiable credentials. Okay. So, it is once again strongly encouraged that you go through this site to get to know more details about VCs, and these are digital representations of credentials. So, just as a driver's license, it could be there on a physical card. So, if this is in the form of a VC, and if I am asked to present my driver's license, instead of presenting that card, I could show it from that digital identity with the verifiable credential. So, that should be equally available in exactly in a simple form to the verifier, and also it should be equally acceptable by the verifier. So, it would be as good as the license that is physically presented. So, it is indeed great that if this is presented in a digital form and which is verifiable, in that case further linking of that license with maybe past cases of different traffic violations or some good service that is provided, or say if it is a VC which is a university degree which can be actually used by the employer in digitally, then they do not have to physically look at a document and check whether indeed it is valid or not. So, this is very useful in many cases where we are trying to machine verify the credentials. So, if this is verified by the machine, then maybe certain types of different services can be provided, certain types of subsidies can be given. So, if we have this VC like which is presenting the information about Aadhaar card, which talks about maybe the family income, and then there are some government schemes that are there for people who are below the poverty line or for different such other types of requirements to be satisfied. So, if the VCs contain those types of information and this can be verified by the machine, then indeed it will be making the entire process very efficient. So, that is the whole idea of having this verifiable credentials which are digitally available, and this can be presented and then verified by the machine, and it would decouple the issuer from the holder and from the holder to the verifier. So, issuer is the one who is issuing the verifiable credentials, and they are issuing it to the holder of the verifiable credential, and then the holder may from time to time present that to the verifier. A typical example would be a university could be the VC issuer for the degree certificate and the transcript. The holder would be the student who has graduated, and then verifier could be an employer, or it could be another university to which the holder wants to get admission to. So, what happens is that the university can issue the VC to the holder after the holder graduates, say in the year 2020. But then the holder is holding on to that particular VC, and then maybe in 2022 the holder decides to go for higher studies. So, in 2002 the holder will be presenting that VC to the verifier, which in this case is the next university where that holder wants to get an admission to. So, that is how this VC would work, and you see that these are all decoupled. So, this is the first university, the holder, and the second university, and you can make your own examples with employers and employees and so on. So, the employers can actually put VCs about the experience of the employees, and even after they leave one company and go to another company, they can also present these VCs, which will show that the previous company had these certified these attributes of this particular employee when he was employed in that previous employer, and the next employer can see what are the skill sets that this person has. And of course, it has to be cryptographically secure and privacy respecting, means that the individual holder would be able to present whichever part of that VC the he or she wants, like we talked about the self sovereign principle. So, that also should be something that can be implemented using these VCs. So, these are some of the important requirements of like the last 4 bullet points that we have mentioned, and then we will see in detail later that how actually this can be done using the verifiable credentials, how this entire process works, and finally, that how a blockchain can help in this particular process. So, with that we will come to the conclusion slide of this particular lecture. We have talked about how DIDs are implemented. In the last lecture, we introduced the concept of DIDs, and here we actually showed how these DID documents look like, how they are maintained in the data registries, and then from there we motivated that what are the problems with centralized these deed registries, and why we need to go for the decentralization of this. And indeed we mentioned that there are these SideTree and Hyperledger Indy, these are the different blockchains which can be actually used, and we have also mentioned that we will have more discussions in the tutorial on Hyperledger Indy, which will follow this lecture after some time. And then this is one of the important applications of blockchains, and an application which otherwise might be very difficult to implement if not using blockchains. And then finally, we said that there is a need to bind those digital identities with some physical identities, and these physical identities initially we are talking about in the form of verifiable credentials, and later on we will see that in the next lecture what are these verifiable credentials, how they look like, how they can be presented by the holder to the verifier, how issuers would issue them to the holders. And finally, in the next lecture we will also talk about how these VCs can be linked to the DIDs. So, it is important that we at this stage understand there is a need for this linking DIDs with the verifiable credentials, and we will in the next lecture we will conclude this discussion on identity management, where we will have more details about the VCs and their linking with the DIDs. And the references, of course, again the web resources that we are mentioning from time to time, it is once again strongly encouraged that you please go through those sites, and you will get a lot more detail, and it will make your understanding very clear beyond what you are seeing in this lecture. So, with that we will come to the end of today's lecture. Thank you very much.